So we talked in general about what a tuple was and how we define Boolean functions. And let's go through a couple of specific examples and how we might do that with a truth table. Let's start with this is all from example 1 from your book, right? So here we have f of x to the 2, so it's a two-tuple, a couple, from the set 0 and 1, and it maps to 0 and 1. So what would that look like if we were to draw that out as a truth table? Well, first we have to, the way we talked about it before, we talked about, you would have x to the 1 and x squared, but that actually is kind of cumbersome to work with and not particularly informative. A lot of times you'll just pick variables like p and q, right? So p and q will be our input variables. Those will be the values in our tuple, and then we'll usually use f, because our function is defined as f, as the output. And then when I do a truth table, I always draw a bar there. I noticed the book did not, so don't worry about it too much. The key thing is when we're doing this truth table only works if there's a finite set. I think in the last video I said that all sets have to be finite. That's not true. I don't know why I said that. I'm an idiot. But if you do have a finite set, you can do a truth table, right? So what are all the possible values of 1 and 0 for the inputs into this function f? Well, they can both be 0, right? The first one could be 0, the second one could be 1. The first one could be 1, the second one could be 0, or they could both be 1, right? So those are all the possible values that you could have, right? And then what is the output going to be, right? What is our f? Again, it's whatever we define it to be, right? So according to the book, it is 0, 1, 0, 1. All right. This is our truth table, which shows all the possibilities for this function. We could also represent this as a circuit, which we'll do later on, or this is, it's not an exclusive or, but there are other theorems that we could use to build this. But this is, at its most basic level, we've just defined a truth table. And let's do the same thing for our for our function g up here. And again, we're going to define our functions as p, q, r, and then g, because that's our function name. And this is the same as x to the 1, x to the 2, x to the 3, right? It means exactly the same thing. It's just easier for human beings to look at p, q, r and to get that. And again, we have to do all possible values. So these are all possible values for P, Q, and R, since each one can only be 0 or 1. By the way, how to figure out how many values are possible, we're going to do that in another example. So yeah, then all we have to do is define. So this is our domain. This is our total domain. Now we just have to define what our range is going to be. Our range is 1, 1, and then all zeros except the last 2 are 1s as well. So with this function g, we know for every possible input what the output's going to be. So you could write a method that did that. You could create a circuit that implemented that. The key thing with example 1 here, none of this is new. This is all stuff we talked about in the last lesson. We're just learning a new way to write it. in a truth table, because these are very, very handy when we're talking about Boolean functions. Okay? Again, remember, as always, if you have any questions, ask them below. You get extra credit for asking questions, and you get more extra credit for answering them.